GMV5 Maintenance Technical Instructions. Maintenance Chapter. This chapter includes 3 parts. Part 1 Precautions for Maintenance. Part 2 Basic Maintenance Procedures. Part 3 Common Troubleshooting and Replacement of Electrical Components. Part 1 Precautions for Maintenance. Security requirements. First, all electrical work must be performed by a qualified, licensed electrician according to local and national codes, as well as the instructions provided in the manual. 2. Only trained, qualified installers and service personnel are allowed to install, start up, and service this equipment. 3. Before installation, modification, and maintenance of the system, the power supply should be disconnected. There may be more than one disconnect switch, lockout, and tag switch with a suitable warning label. 4. It's not allowed to use oxygen or other flammable gases to do the airtight test. 5. All maintenance operations must comply with design requirements of this product and local security operation requirements. 6. When failure occurs to the unit, service personnel shall deal with the failure immediately at the site so as to avoid operation failure and secondary damage to the unit. Part 2 Basic Maintenance Procedures. First, check with the customer for all the detailed abnormalities of the failure during operation. Second, get details about the engineering configuration and installation status, including pipe length, height difference, quantity of indoor units and outdoor units, refrigerant charging amount, etc. 3. Inquiry of failure. There are 2 methods of failure inquiry. One is current failure inquiry, namely inquiry through light board of indoor unit, wired controller, and error code displayed on outdoor unit's LED. The other is failure log inquiry. In this case, the failure has been eliminated and inquiry will be done through debugging software or wired controller. 4. Malfunction elimination. After confirming the failure, please deal with the failure according to the troubleshooting of installation, debugging, and maintenance manual. 5. Confirmation with the user. After eliminating the failure, please explain the cause and operation precautions to the user and make the maintenance record. Operation instructions of low pressure check valve and oil check valve. The outdoor unit is equipped with a low-pressure check valve and oil check valve for maintenance. Low-pressure check valve is mainly for system low-pressure detection and charging refrigerant. Oil check valve is mainly for checking the oil quality in oil balancer. During maintenance, the oil check valve can be used to extract lubricating oil samples, which are further detected to analyze the oil quality in the system. Before the extracting of lubricant, the system must be stopped for at least 12 hours and the internal pressure of the system must be equal to or less than 0.2 megapar. Otherwise, the overheat oil may burn the service personnel. How to locate a faulty indoor unit promptly. Use the Indoor Unit Project Address Inquiry and Faulty Indoor Unit Locating function to locate a faulty indoor unit or wired controller's corresponding indoor unit when multiple indoor units are running in one place. Detailed operation is as below. Step 1. Long press function button for 5 seconds when the unit is either on or off to read the parameters. Step 2. Press up button to show code C01. The engineering address is shown in the timer area, while the failure code is shown in the temperature area. Meanwhile, the corresponding failing indoor unit buzzes. Part 3. Common troubleshooting and replacement of electrical components. This part mainly introduces troubleshooting of common failures during after-sales maintenance. First, communication error, C0. There are two cases for this error. The first case is that both indoor units and outdoor units display C0, which means the main communication cable between indoor units and outdoor units is broken or disconnected. In this case, please check the communication connecting status. The other case is that the outdoor displays normally, but some indoor units display C0, which means the indoor unit with error display is not connected well with the main communication cable, or the white controller is not connected well with the indoor unit. In this case, please check the communication connecting status. In the two cases mentioned above, if the communication cable is connected properly, we can judge that the outdoor or indoor mainboard is faulted. In this case, please replace the corresponding mainboard. 2. Indoor unit deficiency error, C4. When C4 appears, it means the current online indoor units are at least 3 sets less than the quantity confirmed during debugging. The system is not allowed to operate. Therefore, if the indoor units are in maintenance, please make sure the offline quantity is equal to or less than 3 sets. If no indoor unit is under maintenance status, please check the power supply and communication cable status of all indoor units. 3. Indoor unit project address conflict warning, C5. When C5 appears, it means 2 or more indoor units share the same project address. In this case, please set the indoor units in different project addresses manually. The setting methods are as the following. Option 1. Setting on software. Change the repeated indoor unit's project address into other project address. Option 2. Setting through white controller. Operation procedures. Power on. Long press function button for 5 seconds to enter parameter inquiry interface, C00. Continuously press mode button for 3 times and then long press function button for 5 seconds to enter project parameter setting interface. In this case, temperature area displays P00 and press up or down button to switch to P42. Then press mode button. In this case, project address on the timer area is blinking. Press up or down button to adjust project address and select a different indoor unit project address. Press enter button for confirmation and then press enter button again to return to the previous menu. When setting is correct, the system will operate normally. Four. Outdoor unit quantity inconsistency warning, C6. When C6 appears, it means the current online module quantity is less than the quantity confirmed in debugging. The system is not allowed to operate. In this case, please check if the outdoor unit is powered off or the communication cable is connected abnormally. 5. High exhaust temperature protection, E4. E4 is mainly caused by insufficient suction volume of compressor and high pressure. Therefore, please check and solve the problem from the following aspects during maintenance. First, confirm if the cut-off valves of outdoor units are fully opened. Second, insufficient refrigerant amount. If E4 appears when the system has been operated for a while, it means there is leakage in the pipeline system. Please check the pipeline. If E4 appears in the first time of debugging, it may be caused by insufficient refrigerant amount. In this case, please charge additional refrigerant according to the specifications. 3. Run refrigerant. If it is not charged with R14A, the system may not be operated normally. Confirmation of refrigerant. Stop the whole system. Test the system's balance pressure 20 minutes later and convert the pressure into the corresponding saturation temperature. Compare it with the outdoor ambient temperature. If the difference is bigger than 5 Celsius degree, it is abnormal. If run refrigerant is charged, please discharge the refrigerant of the whole system, vacuum, desiccate, and then recharge the correct refrigerant. 4. Ambient temperature is out of the normal running range. Under cooling mode, outdoor temperature should be -5 to 50 Celsius degree, and indoor temperature should be 16 to 32 Celsius degree. Under heating mode, outdoor temperature should be -20 to 24 Celsius degree, and indoor temperature should be 15 to 27 Celsius degree. When the actual ambient temperature exceeds the above-mentioned temperature range, E4 protection may appear, which is a normal phenomenon. 6. Low exhaust temperature protection, E2. E2 protection is mainly caused by too much liquid in the suction side of the compressor. Therefore, please check and solve the problem from the following aspects during maintenance. First, check the exhaust temperature sensor. When E2 appears, please check the discharge pipe and casing top temperature sensor of the compressor to see if they are loose or not installed properly. Make sure if the resistance of temperature sensor is 50 k ohm and measure if the resistance is corresponding to the actual temperature. Make sure the detected value is not offset, then check other possible causes. 2. Electronic expansion valve is not working properly. If E2 appears in heating mode, please check if the outdoor heating electronic expansion valve and subcooler electronic expansion valve operate properly. Please check the following items to see if the expansion valve works properly. Check if the control wire of the electronic expansion valve is connected well to the mainboard, and if the coil of expansion valve is tightened properly with the valve. Power off and then power on the electronic expansion valve to see if the electronic expansion valve is reset. If it is not reset, please replace the indoor unit mainboard. If the above-mentioned adjustments are normal, please check if the refrigerant charging amount is excessive. 3. Indoor electronic expansion valve is not working properly. If E2 appears in cooling mode, please check if the electronic expansion valve of indoor unit operates properly. Firstly, turn on only one indoor unit for cooling mode and other indoor units for fan mode. After operating for 10 minutes, turn off indoor units under fan mode. After 30 minutes, check if the difference between the outlet pipe temperature of off indoor units and low pressure check value is over 5 Celsius degree. If the difference is equal to or more than 5 Celsius degree, it means the expansion valve is normal, or the expansion valve is abnormal. In this case, please check the following items. Check if the control wire of the electronic expansion valve is connected well to the mainboard, and if the coil of expansion valve is tightened properly with the valve. De-energize and then energize the expansion valve to see if the electronic expansion valve is reset. If it is not reset, please replace the indoor unit mainboard. If the above-mentioned judgments are normal, we can confirm that the E2 is caused by the expansion valve. In this case, please replace the expansion valve. 4. Excessive refrigerant amount. If the above-mentioned causes are excluded, please check the additional refrigerant charging amount again. If the additional refrigerant charging amount exceeds the standard charging amount, low suction temperature will be caused due to too much liquid return at suction side of the compressor. Therefore, please check the additional refrigerant charging amount again. If it is necessary, recharge the refrigerant to the whole system. 7. System high pressure protection E1. When E1 appears, please check if the cut valves of gas pipe and liquid pipe are fully opened. If they are okay, please check other possible causes. 2. When E1 appears, power off and then power on. Turn on the units. Reset the unit into the original operation mode and operation quantity, and check if the fans of outdoor unit and indoor unit operate normally. If not, please check the connection wire and mainboard of fan. If everything is okay, please replace the motor. 3. High ambient temperature in operation. The highest outdoor temperature in cooling is 50 Celsius degree, and highest indoor temperature in heating is 30 Celsius degree. When the actual ambient temperature exceeds the limit, protection may appear, which is a normal phenomenon. 4. Pressure sensor is not working properly. Firstly, check the pressure sensor and connection wire to make sure if the high pressure sensor and low pressure sensor are connected properly. If they are connected improperly, please reconnect them. If they are connected properly, please check if the high pressure sensor is in good condition. The checking method is as below. Stop the whole system. After 20 minutes, test the high pressure and low pressure of the system and convert the pressure into the corresponding saturation temperature. Compare it with the outdoor ambient temperature. If the difference is larger than 7 Celsius degree, it is abnormal. Please replace the sensor. If the malfunction still exists after replacement, it means the mainboard is faulted. 5. High pressure switch is not working properly. If E1 appears after power on, but the compressor doesn't start up, it means the high pressure switch is not working properly. Firstly, please check if the pressure switch is conducted with the universal meter. If it is not conducted, the valve is broken and should be replaced. If it is conducted, please replace the mainboard. 6. The pipeline is blocked. Power off and then power on. Turn on the units. Reset the unit into the original operation mode and operation quantity before protection. If it is in cooling mode, touch the liquid pipe along the flowing direction of refrigerant to feel the temperature difference. Check if the difference is big or part of the pipe is frosting. If it is in heating mode, touch the gas pipe along the flowing direction of refrigerant to feel if the temperature difference is big. If the above-mentioned phenomenon exists, it means the pipeline is blocked. 7. Excessive refrigerant charging amount. If the above-mentioned causes are excluded, please check if the additional refrigerant charging amount is correct. If it is excessive, please discharge the refrigerant from liquid pipe until system pressure returns normal. Note: do discharge refrigerant from liquid pipe. 8. System low pressure protection E3. Possible causes. First, the cutoff valves of outdoor units are not fully opened as required. The checking method is the same as E1. 2. Fan is not working properly. The checking method is the same as E1. 3. Low ambient temperature in operation. The lowest outdoor temperature in cooling is -5 Celsius degree. The lowest indoor and outdoor temperature in heating is 10 degree and -20 degree respectively. When the actual ambient temperature exceeds the limit, E3 may appear, which is a normal phenomenon. 4. Pressure sensor is not working properly. 5. The pipeline is blocked. 6. Refrigerant charging amount is insufficient. The checking methods of the 3 points mentioned above are the same as E1. 7. Finally, if the above-mentioned causes are excluded, please check if the additional refrigerant charging amount is correct. If it is insufficient, please discharge the refrigerant from low-pressure check valve until system pressure returns normal. Note: do charge refrigerant from low-pressure check valve. 9. Compressor error detection. When the compressor overcurrent protection P5, IPM module protection P6, or startup failure protection PJ appears, please confirm whether it is anomaly of compressor or the anomaly of IPM module. The confirmation methods are as follows. First, measure the compressor resistance. Measure the resistance between two wiring terminals, U, V, W, of the compressor. The resistance value range should be 0.5 to 2.0 ohm. Measure the resistance to ground of each wiring terminal. The value should be more than 10 megaohm. If not, the compressor is damaged. 2. Measure the operation current of the compressor. Refer to the maintenance instructions of installation, debugging, and maintenance manual. Measure the operation current of the compressor in low frequency stage and high frequency stage under similar high pressure and low pressure conditions. If the value is 3 amperes higher than reference current, the compressor is damaged. Determining compressor fault. Precondition 1. The unit can be normally started. Step 1. If the unit can be normally started, start the unit so as to measure line current of the faulty compressor. For inverter compressors, the current will be deviated by 10% under different running speed and operation condition. Step 2. Check whether the compressor gives abnormal sound. Step 3. Check whether the electronic expansion valve of outdoor unit works properly. Touch the valve and you will feel its vibration during the reset action. A crack sound will be heard as well. Step 4. Check whether the four-way valve works properly. While this valve is normally running, there should be obvious temperature difference between the 4 couple pipes connected. When a unit switches to activate the valve, there will be obvious vibration and sound. Step 5. Measure the resistance to ground of each wiring terminal. The value should be 10 megaohm. If not, the compressor is damaged. Precondition 2. The unit cannot be normally started. Check the solenoid valves of the system, including electronic expansion valves, oil return valves, and oil balance valves. Refer to the previous section for the test method. 10. Detecting IPM protection module. First, before IPM detection, please prepare a digital universal meter and switch it to the diode. Power off 2 minutes and then remove U, V, and W cables of the compressor from the drive board. Make sure the unit has been powered off for at least 2 minutes before testing. 2. Detection method. Use the black probe of the universal meter to touch the point marked by P in the following picture, and the red probe to touch the point marked by U, V, and W respectively. Record readings of the universal meter. Use the red probe to touch the point marked by N and black probe to touch the points marked by U, V, and W respectively, and record readings of the universal meter. 3. Analysis. If the reading ranges between 0.3 volt and 0.7 volt in the above-mentioned 6 scenarios, the IPM module is normal. If the reading is 0 in one or multiple scenarios, the IPM module is damaged. 11. Detecting rectifier bridge. Before rectifier bridge detection, please prepare a digital universal meter and switch it to the diode. Make sure the entire unit has been powered off for at least 2 minutes before detection. Detection method. First, use the red probe to touch the point marked by N and the black probe to touch the points marked by L1, L2, and L3 respectively. 2. Use the black probe to touch the point marked by P and the red probe to touch the points marked by L1, L2, and L3 respectively, and record readings of the universal meter. 3. Analysis. If the reading ranges between 0.3 volt and 0.7 volt in the above-mentioned 6 scenarios, the rectifier bridge is normal. If the reading is 0 in one or multiple scenarios, the rectifier bridge is damaged. 12. Cautions on outdoor unit mainboard replacement. Distinguishing master module from slave module. First, distinguishing by master module deep state SA8 master. Every cooling system has only one master module, set in power off state. If deep is set to 00, it indicates a master module. If it is set to 10, it indicates a slave module. 2. Distinguishing by LED display status. When a master module is powered on, LED 1 is displayed as 01. For a slave module, LED 1 is displayed as 02, 03, or 04. 3. Check the communication status. After the deep setting of mainboard and all wiring are down, power on the outdoor unit and check whether D3 and D4 LEDs are flashing. If the LEDs flash, the outdoor units and indoor units communicate normally. If the status of LEDs do not flash, communication is faulty. Check the communication cables connecting the outdoor units and indoor unit. If the mainboard has been changed, the system should be debugged again. 4. System parameter setting. After system debugging, reset the system parameters as before. Note, debugging is not needed when replacing the slave module. 13. Cautions on replacement of indoor unit mainboard. Cautions on replacement of slave module mainboard. Before replacing the mainboard, please set the deep switch the same as the faulty board. Check the wiring and then power on the unit. No other setting is needed. Indoor unit mainboard deep setting and jumper cap confirmation. Whenever the indoor unit mainboard is replaced, please check if the deep setting and model is the same as the faulty board. For the new mainboard, configure capacity S1, jumper cap U22, fan overload detection terminal CN36, OVC fan, and overflow detection terminal CN35, water DTCT. This should be kept the same as those of the faulty board. Restore new mainboard engineering parameters to factory settings. This step is not required for originally packaged parts. After wiring, whatever the mainboard is for master indoor unit or slave indoor unit, the new mainboard must be restored to factory settings. Setting method. After the mainboard is powered on, long press up button for 5 seconds. If a tick sound is heard, release the button. Note, this step is not required for originally packaged parts. 14. Cautions on replacement of drive board. Replacement steps of drive board. Step 1. Disconnect the power supply of the system. Make sure the unit has been powered off for at least 20 minutes before operation. Set a warning mark beside the power supply. Step 2. Disconnect all connection wires of the compressor drive board. Remove the screws fixing the drive board and then remove the drive board. Step 3. Replace the compressor drive board. Before the replacement, apply some silicone gel evenly onto the IPM module. Step 4. Install the new compressor drive board properly. Attention! Tighten the screws and connect the wires according to the wiring diagram. Checking lubricant. Before releasing the refrigerant, please collect oil through the oil check valve. Connect a rubber hose to the oil check valve at one end and a glass container at the other end. Open the oil check valve. Control oil flow speed. Since the oil is a mixture of volatile refrigerant and lubricant, do not cover the container, or it may explode. After the lubricant is fully collected, record the volume of oil. 16. Replacing compressor. Step 1. Preparation before replacement. Prepare gases for welding rods, and related tools including hexagon, universal meter, pressure gauge, diagonal pliers, combination pliers, needle nose pliers, PVC insulation tape, etc. Step 2. Remove the compressor. First, disconnect the power supply and put a warning sign beside the power switch to avoid electric shock. 2. Clear the electric parts. Before removing compressors lines, temperature sensors, and electric heaters, mark them so that you will reconnect them in a correct manner after clearing. The removed electric box must be placed in a suitable place. It is prohibited to pull the wires of electric box or damage it. 3. Release the refrigerant. The refrigerant should be released from the gas valve and liquid valve at the same time. If it is released from one side only, the sealed screw plate will prevent the refrigerant from releasing completely. Control the release speed. It is recommended to release for 12 hours or more. If too fast, massive lubricant will be discharged with the refrigerant. 4. Remove the compressor. Confirm faulty compressors, including quantity of faulty compressors, compressor position, models, etc. After confirming the compressor information, start removing the compressor. Step 3. Check the compressor oil quality. First, after the compressor is moved out, put it onto a hard ground and shake it. Tilt 30 to 45 degrees to make sure the deposit at the bottom can be drawn out. 2. Put the compressor on a suitable position and then tilt it to draw the oil out through the vent of the compressor. Collect at least 150 milliliter oil and hold it in a glass container. Put the oil under light to check its purity, color, and smell. Good oil will not emit pungent odor. After removing the compressor, check oil quality and make a good record. If the oil turned to black, check oil of the other normal units. The check procedure is similar to the preceding. Note: before replacing the faulty compressors, make sure to block the ports with tapes. They should be kept intact for further analysis. Step 4. Clear the pipeline system. Check pipelines for abnormalities. Charge nitrogen into the main pipeline and clear the pipeline system. Step 5. Replace the compressor. First, prepare the new compressor. The new compressor must be consistent with the faulty one. The sealing rubbers of the suction port and the discharge port of the new compressor and electric box cover must be in good condition. Charge nitrogen for protection during welding. The pressure of nitrogen is 0.02 to 0.05 megapar. Welding powder can be applied during welding. Pay attention to avoid overburning, insufficient solder and blisters, etc. 17. Replace the gas-liquid separator. Note: if the oil inside the faulty compressor is dirty or turns black, the gas-liquid separator needs replacement as well. This is to avoid abnormality from happening inside the gas separator and affecting system safety and reliability. 18. System leakage detection and vacuuming. First, check welding joints for abnormalities. Second, charge nitrogen into the system for leakage detection. When maintaining the outdoor unit and the indoor unit system is normal, you can charge nitrogen into the outdoor unit only. Pay attention that nitrogen should be charged from both the gas valve and liquid valve simultaneously. Nitrogen pressure should be larger than 2 megapar. Then, check specially the welding joints for leakage with soapy water. 3. Finally, charge nitrogen into the system again for pressure check. Close the liquid valve and the gas valve and keep the system pressure up to 2.5 megapar for more than 12 hours. If the pressure remains unchanged, you can arrange vacuuming. Otherwise, find the leakage point first. Make sure the vacuum degree reaches an absolute pressure of 0 megapar per square centimeter and a meter pressure of minus 0.1 megapar per square centimeter. Because only when the vacuum degree reaches 0 megapar per square centimeter, the moisture inside the pipeline system can be evaporated completely. If the maintenance work involves several modules, vacuum air of the oil balance pipe respectively, connect the vacuum pump with the gas valve and liquid valve simultaneously. Vacuum pumps of the specifications below are recommended. (19) Charging additional lubricant. Charging amount is determined by two factors. The first factor is the quantity of compressors replaced. For replacement of one compressor, 1.5 liters lubricant should be added. The second factor is the joint amount from each part. The charging amount should be equal to or a little larger than the joint amount. The amount of the first factor and second factor is the total charging amount. GMV5 series units use FVC68D and FV68H oil. Make sure to confirm the type of the oil first. Oil of other types is not allowed. Vacuuming for 30 minutes or longer before adding oil. Connect a rubber hose to the oil check valve at one end and put the other end of the rubber hose into an oil container. Keep on vacuuming and open the oil check valve. The lubricant will be inhaled into the system by pressure. If the oil is not enough, repeat the above procedures until the system has enough oil. After a required amount of lubricant is added, close the oil charging valve to ensure tightness. After adding lubricant, please continue vacuuming. 20. Connecting electrical components. Install the electric box and connect the various parts to the electric box according to the wiring diagram on the back of the box. Wire the compressors and corresponding electrical heating belts. Attention! Wires should be checked against the wiring diagram beforehand so that they can be connected correctly. 21. Charging refrigerant and checking refrigerant quality. Before charging refrigerant, check its manufacturer and related information. Checking method of refrigerant quality. Measure and check the pressure of entire refrigerant container against the saturation pressure temperature list. Verify the temperature parameter. If the difference between the actual temperature and the parameter value is 3 Celsius degree or more, the refrigerant quality is unsatisfactory. If the refrigerant is proved satisfactory, calculate the additional refrigerant charging amount according to the amount specified on the nameplate and pipe length. For a multi-modular system installation, if the refrigerant of only one outdoor is drawn out before maintenance, add 80% refrigerant of the rated charging amount of that unit, specified on the nameplate of the unit. Start the system for a debugging test. 22. Operation test. Start the units for debugging in different conditions respectively. Turn on all indoor units under cooling mode. Turn on each indoor unit one by one under cooling mode. Turn on all indoor units for heating mode, and then turn on each indoor unit one by one under heating mode. Duration for each operation mode should be 30 minutes at least. After debugging, analyze the data and adjust the unit system to ensure the running parameters of the entire system. For details about each parameters, please consult after-sales persons and technicians. 23. Instructions to users. When the units operate normally, instruct the user about the maintenance method and operation method, etc., in order to guarantee a reliable operation of the system.